Hello everybody and welcome to another Mystery Box Function Challenge. In this purple mystery box there is some math and your job is to figure out what that math is. You can pause this video, go to the link in the description, and then put in as many numbers as you like in the top, see how they come out transformed at the bottom, and use that information to figure out what's inside the mystery box. When you've got an answer, come on back, watch the rest of the video, and see if I get what you get. All right, let us begin. Let's start with a 0. Whoa, so 0 is off the graph here. It gives us 27. Okay, well, let's try a 1 maybe. 1 gives us 8. All right, now we're back on the graph. How about a 2? 2 gives us 1. So this might be a really steep line with a negative slope of -7, I guess. Let's try a 3. And 3 gives us 0. Oh, this does look like a curve now. So maybe a nice steep parabola. Let's try a 4. Maybe this is the vertex we just got at the on the x-axis there. Oh, So it seems like the curve on the left part of this is really steep, and now the curve is more gentle. That's like a slope of -1. I guess we keep going to the right here. Let's try a 5. Now we're getting some symmetry, and I think I recognize this. I think this might be a cubic function, although there's something strange going on with it. But you know, the cubic function shoots up and down on the sides, and then it flattens out in the middle. So I'm going to try some numbers here, like 2.5 and 3.5. So let's try 2.5. See if we're getting that classic cubic. Yeah, there we go. Let's put 3.5 just to be symmetrical. Okay, well, that looks beautiful. There's a couple of things, though, that's being done to this. The center point, where it kind of flattens out here, is on the x-axis, and with just the plain old cubic function, f of x equals x cubed, that would be the case. But it's shifted over from the origin over to the right 3 spaces. To do that with a cubic function, let me start sketching my guess here. So I'm going to put f of x, and I'm going to make parentheses, because to move in 3 spaces in the positive direction, you actually have to subtract 3 from x before you cube the thing. So I think this is part of it. It's not the whole thing going on, though, because the regular cubic function is low on the left and high on the right, because it keeps negative numbers negative and positive numbers positive. Something else is going on here. It looks like it's high on the left and low on the right. To do that, you have to actually flip the whole function upside down. And flipping a function upside down means multiplying it by -1, or in this case, we could just put a negative sign on the front. So that's what I think is happening from looking at the graph. We should test a couple of points here. Let's try putting a 2 in there. So I'd have a -2 minus 3 quantity cubed. So 2 minus 3 is -1, and -1 cubed is -1, and a -1 is a +1. So if I put in 2, I should get out a +1, and I do. Awesome. I think we should try a number we haven't put on here yet. I'm going to put in -1. So I would have a -1 minus 3 quantity cubed. So -1 minus 3 is -4. If I cube -4, I'd get -64. So a -64 would be a +64. So if I put in -1, I should get out 64. Pretty big number. So -1, see if we get 64. And there's 64. Okay, that has convinced me that we're on the right track here. I'm going to go ahead and reveal. Yeah, we've got a negative and then quantity x minus 3 cubed. So that -3 moves it over to the right, and the negative sign flips it upside down. We can graph that as well, and there's that beautiful shape of the cubic function. Well, how'd that go? I think this was a difficult one to sort of tell from the numbers, although when you put in 0 and you got 27, did you already think maybe cubic? Let me know. Thanks, everybody.